Just sleeping in lately. All right. Yeah, I was doing all right. Yeah.
You know me.
Getting by.
We're in the teens. It's a good look. Oh, so I talked to Dr. Barnes about Pi Day.
What do you say?
So normally first period, it's a breakfast bonanza. We have waffle irons going, and we've had people frying up bacon on griddles. And it's truly a wonderful day. That's off the table. But I did ask him, I said, what if people wanted to bring individually wrapped Ziploc stuff? And he said, that should not be a problem.
Yay.
So even though he told somebody else that, and don't advertise that, just like keep it on the down low. Because if people start making a fuss about it, that's usually when they go, it's just easier to say no than it is yes. So that's not, what's today? First? So not this Friday, but next Friday, we'll do that. I kind of want to do it on the 19th and just send you into spring break with a hurrah. But given that we're not going to be here on the 19th, kind of takes that out. And I thought about the 18th too. But anyway, we're going to do it on the 12th. So so we'll send maybe a list around towards the end of this week, beginning of the following week. And if y'all want to start thinking about that, again, I'm writing up a purchase order. And I'm just going to go into Walmart and just buy tons of crap that's individually wrapped. And because I've got like math team club money that I normally use for my banquet at the end of the year. But anyway, I normally have a banquet at my house and just have my students over. But you guys missed that last year because they just kind of canceled the year on us. And it doesn't look like we're going to be able to have 60 to 80 people gatherings at my house again this year. So anyway, I've got that money, so I thought I'd just spend it. Why not spend it on some Pi Day action? So y'all like Little Debbie's? I'm trying to think of what to buy that's individually wrapped. Feel free to text me good ideas, and I'll just add it to the list. But anyway, y'all can be thinking about that too. I mean, obviously, some things wrap better than others. I don't know if scrambled eggs and stuff like that wrap individually in Ziplocs very well, but whatever. Use your cheese dip, you know. But use your imagination, and we can at least have some semblance of.
How many people are?
I think I got 19, 4, 7, 11, 19. Who is that? Yeah. So, yeah, if everybody's here, 19. Take some attendance. But anyway, I thought I'd throw that out there early. You can be processing. Regression. Normally, people come in with some issues from regression. That's totally understandable. So I want to address those. If you want, some of them are really easy to address. And also, I want to talk about the ambiguity of, or the uncertainty of statistics. I mean, you can take statistics and manipulate them in a lot of different directions. You know, I mean, stats, there's a saying that stats are for dummies. It's not really, because it really is helpful. But I can take statistics and make them fit my agenda if I'm willing to be creative. That's not necessarily honest, but if I'm willing to be creative. And people do that all the time. In fact, I know a guy who works in our system who has his doctorate. And he said he was 2.5 years into his doctoral program, and he's writing his thesis. And in writing his thesis, he essentially talks himself out of it. Like he literally starts gathering his information, he's putting it together, and he's like, I have just convinced myself that my thesis is not true. But what do I do at this point? Start over and spend another 2.5 years writing a thesis? So he literally just gathered the information and just said, I can still prove what I want, but I'm going to have to kind of tweak my data a little bit. But that's essentially what he did with the statistics. He just used the statistics that helped him tweak his data, got his doctorate. Oh, well. So he got his pay raise he was looking for and an open door for his next step in life. But point is, sometimes statistics can be misleading. So when somebody throws, and you probably experienced that in life, when somebody throws a stat out there, just be wary of its source and how people can use, take, and leave off certain information. So what I've done is I wanted you to experience a little of that with this work that I gave you. So what is this on page like 90 something? Yeah. So like that first worksheet that we had that I asked you to kind of play around with, like a couple things pop up. So on this first one, I don't think you had any issues with this first one. Typing, oh yeah, you did. On exponential, what went wrong here? Did y'all get an error message on exponential? Anybody? You should have if you did these. And the reason, can anybody tell me why they think they got an error message? Anybody know? Y'all did get an error message, right? For those that did it.
It's like an outlier. So it would be
What's an outlier?
like 1 point.
You know which one it is? Keeping in mind that, and this is something you have to know, on your exponential, logarithmic, sine curves, unlike what we've done with curves, which is shift them up, shift them down, it can't do that. It stays with the original x-axis. So what point here can't show up on an exponential curve? 1, 0. So if you do an exponential regression, it's going to look at that and go, error, and just toss it. Now in real life, keep in mind when people take stats, whether they're measuring speed or time, there's degree of error, isn't there? I mean, if I go and measure, like if you're timing somebody's 40-yard dash time with a hand timer, there's a delay, a human error. So it's possible that this stat really wasn't 1, 0. It could have been 1.1. 0.1 right there would have worked. 0.01 would have allowed you to do this regression. So if somebody asks you to do an exponential regression, you can't do it. It's probably good to note that it doesn't exist. But it might also be good to note you know, depending on this situation, which I know nothing about, but if this is a real life situation, it's very likely that maybe this was just a rounding error, or maybe they rounded down, who knows what. But those kind of points, usually when we say outliers, and you'll see this when we cover stats in a couple days, we're talking about something that really doesn't fit within a certain number of standard deviations. If you're in stats, right? Who's in stats right now? There are a couple of y'all. Yeah. So you probably know about outliers. If you're within like 1.5 standard deviations of the mean, which will make sense in a week, then we consider that an outlier. And usually an outlier is like a really far off score. Like I have an outlier in my calculus classes. Like in one of my classes, we just took this area test. It's notoriously one of the easier tests we have. Everybody made an A, 1 B. In the other class, everybody made an A, 1 B, 1 high C, and 131. Now, clearly that 31 was an outlier. When you consider that 3 people out of 38 people didn't make A's, and well, 4. 3 made pretty close to an A within 12 points. And then there was this 31. Clearly an outlier. If you look at standard deviations, he's like multiple standard deviations away from the mean. Well, his score is going to drag my average down though, right? Maybe 3 or 4 average points and make if I'm really trying to look at the core of the class, he's skewing my results one direction or the other, definitely downward. So a lot of times what people do, and you see this in diving in the Olympics or in events where you have judges, they'll take the scores and they'll throw out the high and they'll throw out the low. Or if they get enough judges, they'll throw out the top 2 and the lower 2. Because, you know, I mean, the Olympics are the Olympics. You've got judges from different countries, right? And they're trying to sabotage one country to help their guys out. So they might give somebody a low score, you know, in hopes to drag their score down. Well, they understand that. So they toss the high, toss the low, And usually the middle gives a better idea of the score. Well, that's sometimes what we'll do here in stats. Now, on your test, if you're worried about, well, how do I know when to do it? You're not going to do that on your test. My test is very black and white and what to do. But I do want to give you some situations here where this kind of stuff shows up so that if you are getting a doctorate one day and you are running statistics and you get something and you're like, man, I really feel like this is exponential, but I got this point that's messing me up. Sometimes we just take those and we go, all right, let's just have it. And in statistics, I think they deal with that more formally. And if you take a stats class, you'll see that you get rid of some of these points sometimes intentionally anyway to get a better idea. But that's what happened there. And then also, if you looked at number 2, I have people every year, and again, we didn't have much time to talk about this, but I have people every year that try to put -5 blank, -4 blank. You can't do that. It's going to throw all those out. So how do you even manage to do regression curves at all when you have these 4 points? Well, you don't enter them in. You just leave them off. Now, the problem with that is it still is providing you information, right? This is literally telling you that, hey, at -5, -4, -2, even at 0, the graph doesn't exist. Now, if you did leave those off and then did regressions for those other 4 points, it's very likely that your R value you find for each of these, your R value might be higher for a linear. It might be higher. I think it ended up being higher for cubic. Did anybody do this and leave off the points?
Yeah, it's 1.
It's perfect right here, isn't it? So that makes me think, oh, well, it must be a cubic regression. But what do you know about cubic curves? They go forever down to the right and to the left, don't they? So the domain is all reals. Well, that doesn't really link with this, does it? So one thing you could do is you could say, all right, well, it's cubic for all x values that are what? Greater than 0. And you could put that condition on it. That would make more sense if you just limited the domain. Okay, like so you would just keep this part of the cubic and not that part in where the point is. Or you could say, hey, it probably is logarithmic because, you know, on log curves, you're completely undefined to the left and it just heads that way. And the R actually was pretty good on that log curve as well, 0.99 something or maybe. And I don't remember about the linear. But the point is, those are things that would come into play potentially. You can't just shut your brain off with statistics. If you do that, then truly statistics are for dummies. I mean, I can make you believe anything with statistics. I can, just by manipulating them in certain ways and having a good argument. So I just want you guys to use your brain. But again, if you are somebody that does like black and white, which a lot of people that are good in math do, they don't like the gray areas. Those are for artists, you know, and dreamers. We like concrete. I just want to know how to do it. Is it going to work out? I might ask you some questions. I might ask you to think, but on problems where you're making calculations, it will be very direct. You're not going to run into situations on your test where you get does not exist because there's a weird point in there. Okay, so you won't have to worry about that, but I did want you to think about it. Did anybody else have any questions on any of this? Yeah.
I got A, but then like B and C.
Okay, so which one shows the most positive correlation? What is the equation of the regression curves? Okay, so on this particular one, most of the time I want you to determine this is look at R values. But on this one, I wanted you to use your brain a little bit. So if you think about months of the year, 1 through 12, I guess starting with January is 1st and February and ending with December. If these are the average monthly temperatures of this month, from high to low, whatever, average monthly temperature. If you plot these, it kind of looks, I think I may have even referred to this a little bit maybe on Friday, but it kind of almost looks like it's quadratic. And when you do a quadratic regression, you actually get a decent little R value. I don't know if it's 0.9 or whatever. I'm not looking at it off the top of my head. But that's got to repeat, right? In Denver, Colorado, you don't go get warm in the middle of the year and then cold, and then the next year just keep plummeting down to Pluto-like temperatures, right? It's going to continue to do what? It's going to continue to oscillate. And if it's going to continue to oscillate, what kind of regression do you think it is? It's a sine regression. Now, if you run the sine regression, it can find that equation for you, but it can't give you an R value, or I don't even think it gives an R squared value. on this on your calculator. And I'm not sure why it does that. Maybe it's too hard to calculate. I don't know. So sometimes I'm just looking for you to actually think about what it's doing in real life. Now, if all you did is have points and I didn't know anything about temperatures, I might run a sine curve, but I'd probably look at quadratic. I'd probably look at cubic and quartic or power regressions, and I'd run them all and look at the highest R value. And in the absence of knowing anything, I would go, you know what? I don't know. I'm just going to go with the highest R value. But we know it's temperature. All right, so temperature rises and falls and rises and falls. Also, what if I were to say, hey, I'm going to mark the tide, the level of the tide. I don't know if you know this, but high tide hits twice a day, or roughly once every 12 hours or so. So you're getting high tide, low tide, high tide, low tide. So when you start about tides, that's how they know 5 days out when you're going to have high and low tide. It's just based on a sine regression curve that they've calculated. Now, sometimes the tides are higher and lower, and that requires a little bit more. But if you ever got to California, like up northern California, north of San Francisco, the water's brutally cold, even in the summer. But if you can go to low tide and find one of those beaches that's real rocky, and you get down in there and you get in those tide pools, it's really cool. I don't know if anybody's ever done that, but you can wade around those tide pools and you can see these anemones. You stick your hand in there and they like go, and they don't hurt you, but they just like close up on you and they're kind of tacky. You can pull these like big orange and purple starfish off rocks that are like massive, but they're so cold they don't move very fast. They're like, it's like rocks. You know, you can stick them back on there sometimes. Anyway, but it's cool, but you got to know when the low tide is, because otherwise you're going to have to go diving. And I mean, when the water gets to here, it's like, oh my gosh, it's freezing cold. Especially in the north. It's cold in LA compared to what we're used to on the Gulf. We're softies and we like, 83-degree temperature water. But out there, it's usually like in the summer, it might be 68. It'll make your lips blue if you haven't been on California beaches. But if you go up northern, the temperature of the water is like 52. I mean, it's cold. Anyway, whatever. But those are sine curves. And even though or sine regression. So if you think about something like that, which is what this one was asking me for. And it says, that shows the most positive correlation. I won't know that from the R value because it doesn't give me one, but I got to know that from common sense. You know what I mean? And if you didn't know that ahead of time, that's fine. But anything that keeps recurring, high, low, over a period of time, that up, down, once you add the time element in there, that up, down is making a sine regression. Okay? Anybody else on anything we've done? Were y'all able to, I think they gave you a problem. If not, we'll do it today, but were y'all able to use the trace to calculate a y at a certain value? Did we talk about that? Yes, I think. Like if you have the thing graphed and I say, hey, and I'm graphing, say, we'll do this today, like height and shoe size. Okay, and we're doing the correlation in this class. And if I say, okay, I've got all these heights and these shoe sizes, and I have this curve now. And I go, you know what I don't have? I don't have a shoe size that goes with 5'10". So if I go to 5'10", and you can use your trace button and enter that X value, it'll spit out the Y value. Y'all know how to do that? Okay. Do you know how to find the X value when you know the Y value? Because you can't enter the Y value. What did I say to do with that? Yeah, do what? You graph the Y value. So if you know the Y value, just graph the Y equation, and that Y equation will intersect with your graph, and then you can find the intersection to find the X value. But if you know the X value, you can trace, and you don't even have to trace up there to go find it. Just get it on trace so you see the X. You go with me? So you see the little X on the graph, and then you can just enter the exact X value, and it'll spit out the point. So make sure you can do that on your test, because I will ask you both those things. And that to me is the real value of a regression. It's using it to approximate what's going to happen in the future or in between points that you know. It's for predictive purposes. You know, if our superintendent comes and asks me, he goes, how's your class doing? You know, or what do you project or whatever. These are things that I could analyze with statistics and maybe give them a projection or give them some analysis. You know, I could predict maybe a trend that the student's having. Yeah, look, their scores keep increasing with this in mind. They might actually peak here. Those are the things that he doesn't want to know about every score you have or every score in my class. He wants to know stats. He wants to know maybe what could happen. Okay? Me giving him a handful of scores or a regression curve, not what he wants to look at. It's like, dude, that's what you're for. All right? Anybody else on anything on this sheet? Okay. All right, so here's what I want you to do. And normally I get over here and I do, I measure the heights of each of you, which is really good because dudes are such liars about their heights 99% of the time. It's like, how tall are you? 6'1", and I go and measure them like 5'10", you know? And then girls are usually pretty honest, I think, because it's like, I don't care, you know, about hitting 6 feet. I don't know what's so special about 6 feet. I was always 5'10", came up a couple inches short. It's like, ugh. And then my son's 6'1", which is so irritating. Anyway, I'm finally taller than my dad because as he gets older, he shrinks. So he's actually shrunk 3 inches. So he's 5 now. And I'm like, yes, finally. But anyway, I can't measure your heights. I had one kid come in here and I said, how tall are you? He goes, 5'11". I said, oh, buddy, it's not going to be your day. And he was 5'6½". And he'd been telling people 5'11", because that's what they listed him on the football roster, 5'11". Because I guess coaches are always trying to stretch the stats, maybe helps in recruiting. I don't know. Whatever. He was the fastest runner in the state that year, but he was still 5'6½". But here's what I want you to do. Lie or no lie. I'm going to put a table up here, and you're either going to come up here, or if you don't want to come up here, you can tell me your information. But we are going to do a class regression. Okay? So to do that, we are going to shrink this down. There's 19 of us. Okay, so we're going to do all right, we're going to do shoe size. We're going to do your age in months. Shoe size, we're going to use men's sizing. So what that means for girls, just so we can all be kind of uniform, what that means for girls, I believe it's -2. Anybody got a comment on that? Is that right? Okay, so if you are a woman's 10, you would be a men's 8. Okay? And then add how many months it's been since your birthday. Everybody got me there? Okay, so like if you're 17 times 12, and if your birthday was in November, December, January, February, that's 3, I guess it's March now, whatever, 3 or 4, add 3 or 4 to that. So we're going to do age, men's shoe, men's shoe size, age in months, and then your height in inches. How do you do height in inches? Hopefully you know this stuff. But like if you're 5'10", which I am, you're going to take that 5 times 12, right, which is 60 inches. In fact, if you're anything in the 60s, then just take your height, you just take your 60 and add the inches. All right, so 5 times 12 would be 60, and then add however many inches. I don't think we have any 4-footers. I think Gabby, your sister, was close. She was like 5 foot on the money. I was kind of hoping for a 4-footer. And I have my record is 4'7". This girl named Lori Chang, who was like SGA president, whatever. She was I don't know if you're in the band and you see the little tiny drum, the little mini drum. They bought it for her, the original one, because everybody else, she couldn't carry the big ones. It was like knocking her over. So they got her this little bitty tiny drum, and she would. But anyway, yeah, that was my lowest. But I don't think I have any 4-footers in here. So whatever height you are, if you're 6 feet, 6 times 12, 72, and then add the rest of the inches. So shoe size, age, and height. If you want to come up here and write it up there, that's great. Just when you write it with your marker, just leave the marker on the ground, and then I'll sterilize them later. And then if you don't want to write it, then just holler it up to me, and I will write it. But everybody's going to need to copy this down. So I need them all up here so that you can copy them, because your homework is going to be to do a regression analysis based on these 19 stats. All right? So if you want to start coming up here and writing them, knock yourself out. Also, try to make it legible. Like, look at it and you can come up one at a time, but look at it when you're done and make sure you can read it. All right, and you're welcome to put a half in there. Like if you're a 9.5, put a 9.5, no problem.
Oh my God.
Come on, guys. Hey, try to do it quickly and get out. I don't want the whole class going down.
I might have stretched the truth. Hey, oh wait, Lily, change my.
Is the person that wrote 10.5, 69, are they calculating their age currently? Or did you forget your, oh, okay. Remember, toss the marker on the floor.
Oh.
Hey, you're 76.
What's that?
Well, I was going to say up against the wall. Do what?
Yeah, like 76.
Yes, I am. Yes, I am. Actually, 6.5.
I'm sure you.
We got an NBA player.
You did put the. Yeah, you have that NBA.
Hey. Is it actually?
Possible is 7.
So we got 1 6-footer.
Actually, quality.
No.
How tall are you, Lou?
How tall are you?
How tall are you?
6 foot.
Are you 6?
Yeah.
Get him, Lily.
I'm looking at you now. You are taller than me. And Mason, you're 6+, aren't you?
6'1".
6'1". Yeah, most of you guys will get it with lies today.
Yeah, we should make that.
My doctor always tells me I'm much shorter than I am. I swear, I can't go with the professional opinion. You're like, I get there and they're like, you're 5'5".
Probably 5'11" to 6.
Yeah, well, they tell me I'm like 5'8.5" when I go.
No, I'm actually an honest 5'10". I've just come to grips with it. 5'10", it's not getting any
My dad's an
better.
honest 5'9", I'm taller than him. But
Yeah. Well, you're a little taller than me, so at least 5'11". Anybody know Sam's? He looks like a 5'10", 5'9". Anybody know his birthday?
He's old. Maybe he's older than all.
He's older than
Oh yeah, he turned 16 like last April.
Yeah.
Really?
Wait, no, he turned
17
last April.
Dang.
He'll turn 18 this year.
So he had his license as a freshman.
Yeah,
Potentially.
he would have, but he just like didn't
Got
get
a lot of
it. I was like, Sam, you need to get your license. That's the only one you can get. He's like, I might. And he just didn't.
I went to a school like Mount Brook is, where you have a junior high. So you're in a different school in 9th grade, and there were kids that had their license in 9th grade, like when you're just with elementary school. I mean, not, but middle school kids. Dude, you were a god. You had your license in 9th grade back then. All right, can y'all read that? Yeah, you're welcome to take a picture of that. But before we take a picture, can y'all look through there? Is there anything you can't read?
Well, I got some good things.
Oh, you want to try to get it? Looks fairly legible.
Is the number 3 like age? Is that still 4 to a 9?
Is that a 9?
Yeah, that's
Anybody else have an issue on what it says? So wait a second. If Sam can throw his information back, he may be sound asleep.
We got size 10,
Size 10.
71 inches.
Yeah, that's not true. We'll let him have it. Wait, no, that's right. That's 5'9".
Wait, that's 5'11.
Oh, no, it's 5'11". Yeah, that's true. 71. And You said April, so
214 months.
214, he's the grandpa. Okay, so those are the 19 for this class. And can you send him this?
Oh, well.
Thanks. And this is going to be a little tedious to type in, obviously. Before you, I mean, you're copying it down right now, but before you do type it in, I want to give you a piece of advice, but I have to wait until you're off of the screen. Okay, so let me give you a hint. As you're copying, if you just want to give me one ear, if you look at page 103, I think it is, on page 103, it's the work we're going to be doing. It says regression classwork homework number 2. All right, and you look down those charts. You do not have to plot the points on those charts, okay? You're going to have all this regression stuff in your calculator. But notice the way I have the chart set up. What am I using for my X value? Shoe size. I'm going to be using shoe size for both of these. So if you want, when you type these in, especially if you want to save this document in case you make a careless error and your answers aren't matching up, because I'm going to do the regression for this class and the regression for my other class separately, and I'll post 2 keys for this, so it'll actually be accurate to this class rather than some other old one. Go ahead and it'll save yourself a little trouble, and you can store this in case you make an error. Put shoe size as your first column. You know how on that one we did with time and speed, we had all the times under the X column or the A column? Put shoe size there, and then you can put age in the B column and then height in the C column. And then when you do your regression, do you remember how you had to choose which you were using? Then you can just choose your your shoe size from one, and then the age, and then go back and use shoe size and then height. And then you don't have to do 2 separate situations. And you can just use whatever column it is you want to use. Is that making sense what I'm saying? Yes? Okay, because I want to leave this for your work. And then what you're going to do tonight, if you look at 7A and 8A, you're going to do 3 regressions. The linear, the exponential, and the quadratic. Just those 3. It doesn't mean they're actually those, but you're going to use those, and you're going to pick the one that has the best R² value, because a couple of these don't have R values, but they all have R² values. Okay? Now, let me ask you a question, just thinking ahead of time. Would you think that in life in general, that shoe size and age would have some kind of regression?
Like a certain point.
Yeah, I would think up until a certain point, you could probably argue, yeah, because as you age, you get bigger, typically, right? So up until, I don't know, girls tend to cap out, not all of you, but like my daughters were done growing in probably 6th, 7th grade. They were done. Like my daughter hit 5'7" in 5th, 6th grade. She was like a giant. No, she had, upper 5'7", close to 5'8" by like 6th or 7th grade. So she was like 4 or 5 inches taller than all the dudes except this one dude named Jack who's like 6'5". But she was taller than everybody in her class, and then over time people started catching up with her. She just peaked quickly. Whereas my son was just a steady grower and just kept growing all the way up through probably 10th, 11th grade. And then he was done. But yeah, you would argue that at some point that's not true. And considering that our interval here, our ages are between what and what? We don't have any in the 190s. Yeah, so we're between 2 and 214. That's a window, a junior year window. I mean, has anybody grown any this year that you know of? It's marginal, right? So do you think that you're going to see some kind of regression that makes sense in a situation where you're looking at shoe size and your ages? I would argue you're probably not going to see anything which means your R squared value is probably going to be what? What's crappy R's? Closer to 0? Well, closer to 0 is worthless. Closer to 1, better and better and better, right? They usually range in that. So an R square value, because it's a decimal, when you square a 0.9, it becomes a 0.81. So these values that are closer to 1 is good. I'm guessing you're going to have a pretty crappy R value there. Now, what about the next one, shoe size and height? What do you think? Do you think the shoe size and your height is proportional in some way? What kind of proportion do you think it is? I would say it's more of a direct proportion. What do you think that shows up as? When you did proportions, you were comparing one fraction to another fraction, right? When you were in geometry, those are direct proportions. Aren't those kind of like slopes? So I would think that's probably more linear. I'm almost willing to bet, not always, but almost willing to bet that when you do a quadratic regression, or maybe even exponential regression, it's going to fit this better and give you a better R value than a linear. Does that mean that it's quadratic? Think of it. What if you plot all these points and you plot them all and you get something like this? You know, age and shoe size. And you draw a line and your line gives you a 0.88 or a 0.91. You're like, it's not bad. But then the parabola gives you even better, right? And maybe it's actually more like this. Because we're starting with like shoe sizes of 6, going all the way through what? What's that? And y'all got some little feet. 11?
13.
Oh, there's a 13 in there? Oh, there we go. Who's that? Got a 13.
Nice.
At 5'10", you may be still growing. You not growing?
I don't feel like it.
I had a dude whose dad was 6'6", and I had him as a 10th grader, and he had a ninth grader, 9th or 10th, whatever. And he had a size 16 foot. His hands were enormous, like his fingers went for days, but he was 6 feet tall. And he's like, yeah, I'm still growing. Never grew another inch. That dude's going through life with these like mammoth hands, huge feet, 6 feet tall. And then there's a dude who taught here. He actually lives in Homewood. Y'all know, anybody know the Connors? Mark and Colleen Connor. Well, he used to teach physics here. He teaches at Hoover, I think, and at UAB some because he's got his doctorate. But he's 6'3", and I kid you not, I don't even know how he remains upright. He has an 8.5 men's shoe, and he's 6'3". Like truly, it's like little. Probably shouldn't video this. He's got like little geisha girl feet. Like I don't even know how he stands. And he's actually pretty athletic, can play some hoops, plays tennis, stuff like that. But literally, I mean, look at an 8.5. Any girl have a? You probably don't. Anybody? You got a 10? 10.5?
In women?
Yeah, because that would be an 8.5 men's. Okay, yeah. Imagine those tiny feet on a 6'3" guy. I don't even know how he doesn't fall over. Anyway, yeah, it's not always a perfect regression, but you're going to see a lot of times on a curve like this, you could go, you know what? I could really see a quadratic fitting this better. But what would that mean? Does that mean at birth, you got to lose some length on your feet for a while before it takes off? Right? Or what if the curve looked like this? What if it was kind of looking like this? Does that mean at birth you had like, I don't know, negative feet? Like sometimes you got to jump in there and go, okay, again, I don't care about the R value. It's helpful. But again, statistics are for dummies if you're not being careful. Make sense of the R value. I would argue height and shoe size, you have to go with the linear because there's a direct proportion, which is like slope. For every height, shoe size, height, shoe size, height, shoe size. That's probably what's happening, give or take. It's not perfect because we're all unique people. You tracking with me? Okay, so do those. Everybody got this? I need to take a picture of this. All right. So guys, that's on the back of your sheet. So if you go back to the front, I just want you to, I'm erasing. All right, so calculate the R values, write them down. Is this considered a good or decent correlation? We've kind of already talked about that. Does it seem like these should have correlations? We've kind of talked about that. And when could age and shoe size actually be considered correlated? And then on 9, 10, 11, here's where I really need you to understand this. So right here, we're basing 9 and 10 on number 7 up here, and we're basing 11 and 12 on number 8. But this is just giving you a chance to make sure you can use this graph, right? Because when you do this regression, it's going to spit out a curve. Use this curve to say, all right, if I give you a 37-year-old person, which is 444 months, I'm giving you what value, the X or the Y? If I tell you what shoe size would a 440-month-old person, I'm giving you the Y value, aren't I? So how are you finding the X value? I'm graphing Y equals 444. If you graph Y equals 444, that's going to be considerably high on your curve, isn't it? So you're going to have to change your window to be able to even see where these intersect, and then you got to go find that intersection. Just be aware of that. You're going way high, right? And then on number 10, it says, based on the regression, how old would somebody be if they had a size 30? Well, size 30 is your X value. You can just trace, hit 30, and go, and it will jump right to that point. So make sure you can do these. I gave you one each for each of these. I changed this last year so it wouldn't be so tedious. And then one thing we did not do on Friday is we didn't talk about, so I'm kind of doing your homework for you, but we didn't really talk about 3, 4, 5, and 6. So if you jump back to 3, 4, 5, and 6 and take a look at those, population growth and a calendar year. What kind of regression do you think would fit the growth of a population over time? That's exponential growth, which is normally population. Is that going to be always true? Of course not. I mean, especially with limited populations. The more statistics we have, the bigger the numbers, the more accurate we're going to have, right? But you see all kinds of things come into play, like worldwide epidemics that kill millions of people, or wars that take out populations, or famine, and all kinds of stuff like that. But over time, in a certain calendar year, I would argue regression. You know what's going to eventually happen on this earth? You know, if the earth continues to grow, it can't sustain, 400 billion people. So at what time, what's going to finally happen to this exponential curve? It's going to flatten out. You know what that becomes then? Stats people, do you know what kind of curve that kind of grows exponentially and then flattens out? Do what? Close. It's called logistic. Right? So it's not a logarithm, but it's a logistic curve. And it kind of grows exponentially, but it has kind of a ceiling on it. We're not going to get into that, but I just threw that out there. What about B, carbon-14 dating process? Do y'all know what carbon-14 dating is? It's like half-life. So a half of a life, if I have this much carbon at a certain window, and then say 100 years later, I have half that amount, and in another 100, I have half that, and in another 100, I have half that. What's happening here? What kind of curve does that? It goes to half, and it flattens out and never hits the asymptote. What does that sound like? Exponential can grow two ways, can it? It can grow or it can decay. That's an exponential curve. It's just getting smaller. Bacteria growth in time. Exponential again. A lot of these exponentials. What about depth of water and pressure? You ever swum really deep and your ears start popping? I know you may not think about it, but literally, if I were to go and put a gallon of water on Spencer's head, he would feel the weight of that, right? It's about 14 pounds. So, or give maybe not, no, 8 pounds. It's about 8 pounds, he'd feel that. But if I put 100 gallons on him, it's going to hurt him. Okay, that's a lot of weight on him. Well, when you swim deep, that water is on you. Okay, that water pressure is on top of you. That's why you have to have suits and things like that, or your watch will crack at a certain depth or whatever, or at least the water will break the seals and get in there at a certain depth. So that pressure over time, for every foot you go down, it's more weight. What does that sound like if every foot there's more weight on it, more pressure pushing on you? Sounds very direct or linear. Height in the air and temperature. Do you know that every time you go up 1,000 feet, it usually drops 2 degrees, which is why you get up in the mountains, you get up 7,000 feet higher than you normally are, and the temperature drops 14 feet. Sometimes it's more than that, but whatever. On average, that's about right. What does that sound like? Every 1,000 feet. Linear. Height of a ball thrown and time travel. Height of a ball over time. I throw it up, right? As it slows down, comes back down. But if I do it over time, slows down, comes back down. Well, that's true too, but even on every bounce, right? That would be, you could say, an absolute value of a quadratic, but it's a quadratic curve, right? Quadratic goes up, comes down. You know that about, I think you know that about that. Height of the tide and time of day. Sine, and you could argue cosine just as easily, but a sine curve or a cosine curve. So those kind of things I kind of want you to be familiar with, but and I very well could ask that on a test as well. All right.